Assalamualaikum and hi everyone. Okay, so today we are going to proceed with the next chapter, chapter 7, haloalkanes, or also known as alkyl halide. Okay, so we have 7.1 Introduction to Haloalkane and 7.2 Chemical Properties of Haloalkane. So let's see the first subtopic, Introduction to Haloalkane. For learning outcomes, end of the lesson, students should be able to draw structures and classify primary, secondary, and tertiary alkyl halides. B. Name the primary, secondary, and tertiary haloalkanes according to the IUPAC nomenclature. And the last learning outcome is to describe haloalkane as compounds that contain polar bond and the carbon bearing the halogen is susceptible to nucleophilic attack. Haloalkanes or alkyl halides are compounds that contain halogen atom as functional group. In alkyl halide, halogen atoms are bonded to sp3 hybridized carbon atom. General formula for haloalkane is Rx or CnH2n plus 1x for a cyclic compound or CnH2n minus 1x for cyclic compound. X is a symbol of halogen atom that can be fluorine, chlorine, bromine, or iodine. Classification of haloalkane. Haloalkanes are classified based on the carbon atom to which the halogen is directly attached. First general formula is CH3X. It is classified as methyl halide since halogen is bonded to methyl group. Second general formula is RCH2X. It is classified as primary halide where halogen is bonded to primary carbon atom. And then the third general formula is R2CHX. It is classified as secondary halide where halogen is bonded to secondary carbon atom. The fourth general formula is R3CX. So this is tertiary halide where halogen is bonded to tertiary carbon atom. Okay, then we have aryl halide where halogen is bonded to aromatic ring or benzene ring, and then benzylic halide which is not an aryl halide. So this is classified as primary halide because X halogen is directly bonded to primary carbon atom. Now let's see the example on how to determine the class of haloalkane. So we have to focus on carbon that bear the X atom. First example, bromine is bonded or attached to primary carbon. So it can be classified into primary haloalkane. For second example, chlorine atom is attached or bonded to secondary carbon. So it can be classified into secondary haloalkane. For the third example, if you expand this structure, so you will get this carbon with tertiary class. So it can be classified into tertiary haloalkane. And then the fourth example, so let's see carbon that bears chlorine atom. So this carbon are bonded to other 3 carbon atom. So it can be classified into tertiary carbon. So the class of haloalkane is tertiary. Okay, now let's proceed to other exercise on how to classify haloalkane. So the first question, so let's focus on carbon that bears chlorine. So this carbon, okay, can be classified into secondary carbon. Thus, this compound is classified as secondary haloalkane. For second exercise, so let's see the carbon that bears iodine atom. So this carbon has primary class. So this compound can be classified into primary haloalkane. The third question, okay, so let's see carbon that bears bromine atom. So this carbon is bonded to 1, 2, and 3 carbon. So it can be classified into tertiary carbon. So this compound or this haloalkane is classified as tertiary haloalkane. Okay, nomenclature for common name. First, we have to name the alkyl group before its halide. So we have ethyl group, which referred to 2 carbon that is bonded to chlorine atom. So it will be named as ethyl chloride. Second example, we have fluorine atom that is bonded to isopropyl structure. So it will be named as isopropyl fluoride. The third example, we have 6 carbon in cyclic structure as alkyl group. So it is called cyclohexyl. So this cyclohexyl is bonded to iodine and it will be named as cyclohexyl iodide. The fourth example for common name is bromine atom that is bonded to sec-butyl structure. So it will be named as sec-butyl bromide. So please bear in mind that else than isopropyl and sec-butyl structure, you also have to know or remember the structure of nu and also third as well. For nomenclature using IUPAC, haloalkanes are named as alkanes with halogen as substituents. It locate and number the parent chain from the direction that give the substituent encountered first, the lower number. Halogen substituents shown by prefixes fluoro, chloro, bromo, and iodo. So they are listed in alphabetical order along with other substituents. In naming the compound, prefix, parent, and suffix are used. So for IUPAC nomenclature, first we have to find out the longest continuous carbon chain where X is bonded to it. So in this case, carbon 1 is given from the left side of chain to give the X or substituent lower number possible. So this is carbon 1, carbon 2, carbon 3, and carbon 4. So the name of parent alkane with prefix indicating the halogen substituents preceded by number indicating the substituent's location. So bromine is bonded to second carbon. So it will be named as 2-bromobutane. Next example, we have chlorine atom as substituent that is bonded to 6 carbon cyclic structure. So parent name is cyclohexane while chloro as substituent. So it is named as chlorocyclohexane. The third example, in naming substituted cycloalkenes, numbering begins at and continues through the double bond. So we have important functional group which is alkenes. So this carbon is given number 1. This is position number 2, number 3, and number 4. So bromine as substituent is bonded to carbon number 4. Thus, this compound will be named as 4-bromocyclohexene. The fourth example, so you have to trial and error. If you start numbering carbon 1 beginning at the left side of chain, 1, 2, 3, 4, 5, 6. So bromine as the first substituent will get position number 1. So chlorine position number 3, and methyl as the third substituent will get position number 4. So set of locane is 1, 3, 4. If you begin numbering the carbon at the right side, 1, 2, 3, 4, 5, 6. So you will get methyl as the first substituent will get position number 3, chlorine as the second substituent will get position number 4, and bromine, the third substituent, will get position number 6. So the set of locane is numbered as 3, 4, 6. So we have to choose lower set of locane. So C1 will begin at the left side. So this compound will be named as 1-bromo-3-chloro-4-methyl hexane. So please bear in mind that in naming the compound, you should arrange it alphabetically. So another example, okay, we have to find longest continuous carbon chain. So we have 6 carbon here. So parent is hexane, and then on carbon number 2 we have first substituent, that is methyl, and on carbon number 4 we have methyl and also fluorine as the second and third substituent. So we should arrange it alphabetically. So it is named as 4-fluoro-2,4-dimethylhexane. So di here stand for 2 identical substituent which are methyl. So second example is chlorine atom, which is bonded to benzyl group or benzyl structure. So it will be named as benzyl chloride or chloromethylbenzene. The third example, we have benzene that is bonded to toluene as parent. So CH3, okay, will get carbon number 1. So chloro as substituent as carbon number 2. So the name would be 2-chlorotoluene. For next example, okay, longest continuous carbon chain, we have 4, 5, 6, 7. So 7 carbon heptane, and then on carbon number 4 here we have substituent. So carbon that is bonded to parent chain is numbered as carbon 1. This is carbon 2. So fluorine is bonded to carbon number 2. So that the name would be 4,2-fluoroethylheptane. And the last example, so carbon 1 will be given here since these two substituents will get lowest number possible. So chlorine will get carbon number 2. Okay, so parent name is cyclopentane since we have 5 carbon here. So chlorine is on carbon number 2 and 2-methyl on carbon number 1. So we'll name it as 2-chloro-1,1-dimethyl cyclopentane. So these are examples of polyhaloalkanes names. For example, we have CH2Cl2. IUPAC names is dichloromethane, but common names is methyl dichloride. CHCl3 is trichloromethane and common name is chloroform. CCl4 tetrachloromethane and common name is carbon tetrachloride. Exercise 1. Give IUPAC name and classify this haloalkane. For question number 1, first we have to find the longest continuous carbon chain that include X along the chain. So if you start or begins numbering on the left side, so we'll get parent chain, heptane as parent chain. Okay, so on carbon number 2, okay, we have first substituent that is methyl. Carbon number 4, another methyl group, and then on carbon number 5 is bromine. So this is the first set of alkane. Okay, if you start numbering from the right side, still you will get heptane as a parent, but first substituent that is bromine will get position starting with number 3, and then methyl number 4 and another methyl on carbon 6. So here we have to choose lowest set of alkane for naming. So that I will choose 2, 4, 5 instead of 3, 4, 6. Okay. So the name would be 5-bromo 2,4-dimethylheptane. Okay. So halogen, okay, which is bromine, is bonded to secondary carbon. So this class of haloalkane is secondary. Okay. For second question, okay, if you start numbering from the left, 1, 2, 3, 4, 5. Okay, so you will get pentane as parent. Okay, while bromine, okay, as first substituent with position number 1, and then chlorine on position number 3, and then methyl on position number 4. So you will get set of alkane 1, 3, 4. But if you start with beginning from the right side, 1, 2, 3, 4, 5. Okay, so methyl, okay, will get the position number 2, and then chloro number 3, okay, and bromine number 5. Okay, so we have to choose lower set of alkane. So we'll choose 1, 3, 4. So the name, okay, if you arrange it alphabetically, so it would be 1-bromo 2-chloro 4-methylpentane. So this is a primary haloalkane. Okay. For question number 3, primary haloalkane is for bromine, okay, while chlorine is secondary haloalkane. Okay, so for question number 3, if you start from the left side, okay, numbering 1 2 3 1 2 3 4 5 6 7, so you will get heptane as a parent. Okay, so set you will get methyl on carbon number 2, and then bromine on carbon number 5. Okay, if you start from the right side, 1 2 3 4 5 6 7, so still heptane as a parent, but bromine will get position number 3 and methyl carbon number 6. So I'll choose the lower set of locant to 5, so it will be named as 5 bromo 2 methyl heptane. So here this haloalkane is classified as secondary haloalkane. Okay, so let's proceed to exercise number 4. Okay, so for exercise number 4, if you give the numbering starting from the right side, so this is carbon number 1, number 2, number 3, number 4. So meaning, okay, fluorine, okay, will get position 1, and then methyl here, okay, position number 3. Okay, so if you start from the left, so this is carbon number 1, number 2, number 3, number 4. So meaning, okay, first substituent is methyl located on carbon number 2, and then fluorine as second substituent, okay, located on carbon number 4. So lower set of locant is 1 3. Okay, so the name would be 1-fluoro 3-methylbutane. So this is a primary haloalkane. Okay, next we go to exercise number 5. Okay, so for exercise number 5, okay, so we have 1 2 3 4 5 6 carbon in cyclic compound, so it will be named as cyclohexane. So iodine, okay, is bonded to carbon number 1, so iodocyclohexane. Okay, so this carbon is a secondary carbon, so class of compound is secondary haloalkane. Okay, and then the last exercise, okay, so longest continuous carbon chain. So if you start with this carbon, so you will get 1 2 1 2 1 2. Okay, now, okay, if you start with this carbon, 1 2 3, so longest continuous carbon chain is 3 carbon, so your parent would be propane. Okay, so on carbon number 2, you have 2 substituent, that is chloro and also methyl. Okay, so the name would be 2-chloro 2-methyl propane. So okay, this carbon is a tertiary carbon because it's bonded to 3 carbon atom. So this class of haloalkane is tertiary haloalkane. Okay, so for 7.1 we have finished all the slide. Okay, so let's proceed to 7.2 afterwards. Okay, so these are the answers. Okay, for question 1 until question number 6.